In this video, we're going to talk about limits at infinity. So if you're given a graph and you're asked what is the limit as x approaches infinity in this way, when the infinity doesn't have a sign, it means we're talking about positive infinity. And this means we're talking about really huge values of x. So where are the huge values of x? They are here. I'll use red to label it. So any value of x that is on this side. Yeah. So basically, as x getting bigger and bigger and bigger, what's happening to the points on the graph? I can see that the points are getting really close to this horizontal line. And this horizontal line has a y value that is 2. So as x approaches infinity, so as x increases, the graph approaches the value 2. In this case, I say limit as x approaches plus infinity is equal to 2. Now, if the question, what is the limit as x approaches negative infinity of the function f of x? Again, negative infinity, it means I'm talking about small values of x, or I can say as x decreases. What's happening when x decreases? I can see that the graph is getting smaller and smaller and smaller, and it's going down. When I say it goes down and it doesn't have a bound, it doesn't stop somewhere. Even in the graph, when you see the black one, it stops there because this is the graph given. But can I extend? Yes, I can keep going and going and going. In this case, I say limit as x approaches negative infinity because it's getting smaller and smaller. It's going the negative way. I say it is equal to negative infinity. Now, in the case where you have limit as x approaches infinity of the function is equal to a number, then what can I conclude in this case? I say y equals to 2 is a horizontal asymptote. So how do we get horizontal asymptote? Whenever I do limit as x approaches infinity of a function and it's equal to a number, then you say y equals to that number is a horizontal asymptote. Now let's check the other figure. What's happening when x increases? As x getting bigger and bigger, I can see the points are getting bigger and bigger and they don't stop somewhere, so I can keep going. If I take more points here, I can keep going like this. So it doesn't have a bound, it doesn't stop somewhere. So basically, limit as x approaches infinity here in this case, which is positive infinity of the function, is plus infinity. Whenever you do limit as x approaches infinity and you get infinity, it means we don't have a horizontal asymptote. Now, limit as x approaches negative infinity of the function. Here, if I check limit as x approaches negative infinity, I can see that it's a horizontal line and it stays the same. So all the points, they have the same y value, which is in this case -1. So I say it is equal to -1. In this case specifically, from this graph, whenever you have horizontal line, we don't say that y equals -1 is a horizontal asymptote because the function itself is y equals -1. It's just a horizontal line. And the definition of asymptote, it's a line that the graph cannot touch it and cannot cross it if you want. Now, if I look at the third figure, what's happening when the x values are increasing? I can see that the graph is increasing in this way. So limit as x approaches plus infinity, or infinity in this case, will be plus infinity. And limit as x approaches negative infinity, I will check what's happening. So as x approaches negative infinity, you're going to the negative side and like this. So you check the points on the graph, they are going up and up, they're taking bigger values of y. So the y values are getting bigger and bigger and bigger. So the limit in this case, we see it's going to plus infinity. Okay, I hope this was clear. Now we're gonna do it algebraically and talk about asymptotes. Alright. Let's say you have limit as x approaches plus infinity of x squared minus x plus 3 over 2x cubed plus 1. Now whenever we have limit as x approaches infinity of a rational function, we call this rational function because it's like fraction. We have polynomial on top, polynomial down. Then the fastest way to do this limit is to take the term with the highest exponent on top, which is x squared, over the term with the highest exponent down. Always you do the same idea. If the limit as x approaches plus infinity or negative infinity, you do the same thing. Take the highest exponent on top, the highest exponent down. And don't mix this whenever x approaches a number. If x approaches a number, then you have to replace first. If you get an answer, that's it. If you don't, then you have to factorize and try to simplify as we did in the previous video. But whenever it goes to plus infinity or minus infinity, in this case, you take the highest exponent on top with the term with the highest exponent down, and then you simplify. X squared, all of it will go. It becomes 1. And from the 3 here we took 2, we still have 1. So it becomes 1 over 2x, which is 1 over infinity. Usually we don't replace infinity, we don't try that. But I'm gonna write it for you to understand. And whenever we have a number over infinity, as I said before, the answer is 0. I think also I mentioned before number over 0, and this answer is infinity. So these will help us evaluating the limits. So once I get 1 over infinity, I know that my answer is 0. Now, knowing that limit as x approaches infinity, it's equal to a number, it means directly I conclude that y equals 0 is a horizontal asymptote to the graph, for sure, to the curve. Okay? If you're confused to write y or x, then this is how you can tell or to remember it later on. X approaches plus infinity, so no way for the x to be a number. So no way here we're talking about x equals a number, okay? So the value 0, it must be the y. That's why I wrote y equals 0 is a horizontal asymptote. Now limit as x approaches infinity of 3x squared plus 8x minus 4 over 2x squared plus 4x minus 5. Then again, limit as x approaches infinity of a rational function, then we have to take the highest exponent on top, so the term with the highest exponent, which is 3x squared, over the term with the highest exponent down, 2x squared. Then the x squared and x squared will cancel. We get limit as x approaches infinity of 3 over 2, which is 3 over 2. So limit as x approaches anything of a number, it's just the number itself. In this case, limit as x approaches infinity equals a number. We say y equals 3 over 2 is a horizontal asymptote. Now, limit as x approaches infinity of x cubed plus 8x minus 4 over 2x squared plus 4x minus 5. So again, we apply the same idea, and we take the term with the highest exponent over the term with the highest exponent down. When I cancel this time, the square down, or it will cancel, the 3 becomes 1. So I get limit as x approaches infinity of 3x over 2. Now when I replace infinity, and I said we don't usually replace infinity, just I'm writing it for you to understand. So 3 times infinity, imagine you're doing 3 times 1 billion. Okay, you're gonna get a very huge number. over 2. It's still gonna be a very huge number, so in this case the answer will be infinity. And when I say infinity, it means positive infinity. In this case, when we have limit as x approaches infinity is equal to infinity, we say we don't have a horizontal asymptote. We might have something else. We're gonna talk about it maybe later on. Talking about the same functions, but limit as x approaches negative infinity, actually it's not gonna change anything except in the last one. So again, we do limit as x approaches negative infinity. We take the term with the highest exponent over the term with the highest exponent down. We cancel this and this, and we get limit as x approaches negative infinity of 1 over 2x. Now, when I replace, it's gonna be 2 times negative infinity. Again, 1 over 2 times negative 1 billion, let's say. If you try to do it on the calculator, it's gonna be minus 0.0000 something. So, which is 0 in this case. So always remember, number over infinity, if it's a plus or minus infinity, the answer will be 0. And again, in this case, we say y equals 0 is a horizontal asymptote. Now for the second one, limit as x approaches negative infinity, we take the highest over the highest, we cancel x squared, and the answer will be 3 over 2. So in this case, y equals 3 over 2 is a horizontal asymptote. Now in the last one, limit as x approaches negative infinity, we take the 3x cubed and 2x squared down, we cancel, and we get limit as x approaches negative infinity of 3x over 2, which is 3 times negative infinity over 2. Now whenever you multiply positive with negative infinity, you're gonna get negative infinity divided by 2. I'm writing in details. As I said, we don't replace infinity, you can just do it mentally. And then minus infinity divided by 2, like you are doing minus 1 billion divided by 2, it's gonna be still a very huge number, which is negative infinity. Just you need to pay attention whenever you're replacing, and then let's say you have minus 3 over 2 negative infinity. In this case, the answer will be plus infinity, so the minus and minus will become plus. In case you have a negative number down, you get an answer minus infinity over negative 2. So again, the minus and minus will change to plus, and the answer will be positive infinity in this case. So just pay attention to these cases. Right?